So the next thing that we want to look at is, now that we have the NICs reprovisioned, they all have fabric failover enabled, we want to know what happens to IP connectivity to this end host if we lose all the uplinks from Fabric Interconnect B to the 5Ks. Okay, in the previous case we did that, we saw that we lost connectivity, okay, because we didn't have an alternate path. So we're going to go over to the 5Ks and we're going to shut down port 11 on 5K1, and we're going to shut down ports 9 and 10 on 5K2. What ideally we should see happen is that the vETH that is corresponding to vNIC1, okay, for the service profile, so this is going to be on chassis 1, slot 4, okay, so blade number 4 on the chassis has vNIC1. This is being logically represented by a virtual Ethernet. So if we look at FIB and show MAC address table for VLAN10, we see this is vETH 711. And if we show pinning for interface vETH 711, we see this is going up to port channel 102. If we show port channel summary, port channel 102 should have interfaces 3, 4, and 5. All of them are currently up. So we're now going to go to the northbound switches on 5K1. We're going to shut down port 11. We should see that this does not affect connectivity, okay, because we still have multiple interfaces in the channel. We're looking at the bottom ping here. Okay, so we still have connectivity. We go over to 5K2. And before I make this change, okay, what I'm going to do is to shut down ports 9 and 10. So let's go to, let's say, config T, interface E1 9 to 10, shut, end. Okay, so that's going to be our config to shut it down. Before we do this, though, let's again ping to 10.0.0.102. Show IPR pipe include 10.0.0.102, and then see where we're learning this MAC address. So show MAC address table for the address. This guy right now should be on port channel number 2. So if the fabric failover works, what we should see happen is that we drop the physical links to the FI. The FI is going to tell the IO module that, hey, we lost connectivity to the northbound network. Anything that is pinned to me and has fabric failover, you need now to move this from fabric B over to fabric A. So we're essentially telling the network card, the VIC adapter, that moved the traffic physically behind the scenes from one trace to the other. So in order to support this feature, you need to make sure that the hardware actually supports it, which not all of the adapters on the blades do. Okay, VIC 1240, 1280, 1340, 1380, those ones do support it. But if you look at some of the legacy, like the Intel, Emulex, or QLogic cards, those ones support it only in software, not in hardware. Okay, so let's run that command. And then right afterwards, so we're going to end, and then I want to run one more command after this, which is show MAC address table for this MAC. Okay, if this works, we should see almost immediately that this is going to change to port channel 1. And notice that from the OS point of view, we lost just one ping, but we're maintaining connectivity. So anything that was previously using Fabric B now moves over to Fabric A. So if we look at the MAC address, we see that we're still learning it, okay, but it moved physical interfaces. So it moved from logical port channel 2 to logical port channel number 1. If we now go over to Fabric Interconnect A, previously the 9F address was not known. Only the 8F was known. So if we look at the MAC address table again, what we should see is that there is now a local vETH that corresponds to this MAC. Okay, notice that it's 712. It normally is going to be one more number than whatever it was on the other fabric. So this is 711 is the primary network card. The failover NIC should be the next number up. It should be vETH 712 on Fabric A. Okay, likewise, we have vETH 709 on Fabric A. This is going to be the primary port for vETH vNIC 0. Then if we look at vETH 710 on the B side. So let's show interface brief pipe to include veth. 710 is going to be the failover NIC for the other side. Okay, right now this error message here, ENM source pin fail, this means that there's not a physical uplink for us to follow from the fabric interconnect to the northbound network. This error message is what's now informing the OS that, hey, you need to fail over to the other side. Or in this case, it's not actually the OS, it's the network card itself, the VIC-1240 that we're telling pinning failed for whatever reason, either because I lost a physical uplink or because it was misconfigured. The end result is that you need to fail over to the other side and see if you have gained connectivity there. Which in our case, if we go to Fabric A and show interface brief, pipe to include the veths, we should see that these veths are all up. And if we look at the show pinning for interface veth 712, so this is where our traffic is actually going, this should be pinned to port channel 101, which is towards the VPC pair northbound. Okay, if the failure were to be restored, so on 5K1 we no shut the port, we go to 5K2 and look at the MAC address table, we should see that this is going to change to the peer link. Okay, it should change to port channel 34. Now the healing of the failure, so the reconvergence after the failure is restored, is not as fast as the initial failure, but from an operational point of view, we don't care about that because traffic is already flowing on the failover side. Fabric B comes back, okay, we give it a little time to reconverge, then we move the NIC back. Okay, now it's moved back to Fabric B. From 5K2's point of view, though, it doesn't have direct connectivity to Fabric B. It's having to go over the VPC peer link in order to get there. Okay, reason why is that if we look at the show VPC, local leg of port channel 2 is down. Okay, so that asterisk means we're forwarding over the VPC peer link in order to get there. So if we now bring these interfaces up, let's show port channel summary. Port channel 2 is interfaces 9 to 10. So interface E1 9 to 10, no shut. If we go to Fabric Interconnect B, we should see now that these interfaces, the virtual Ethernets go up. Okay, which they do, so they're now trunking. And if we look at the MAC address table again and look for that MAC that is the 009F, we should see that this is moved from Fabric A to Fabric B. So Fabric A no longer knows the address. Fabric B should see this on 711. So it moved back to where it was originally. From the 5K's point of view, 5K2 should see this move from port channel number 34. It should move to port channel 2, which is the local VPC member. Now the same is going to be true since I enabled Fabric failover on all 4 of these NICs. It means that the same should be true when we're failing from, if the A side goes down, A traffic is going to move over to B. Okay, that should be for our other host. So if we go to 5K1 and we ping to 20.0.0.101, we look at the show IPR pipe to include 20.0.0.101. This corresponds to this address. If we look at the show MAC address table, pipe to include that value, we should see that both of the 5Ks are learning it on the same channel. Okay, they're both learning it on the channel to Fabric B. We go to Fabric A doesn't have this. Fabric B, however, should. Okay, if we go to 5K1 and we shut down port numbers 9 and 10, on 5K1 we shut down port 11, we should see now Fabric A is going to learn the address and the failover should be complete. So we should see that this is going to change from port channel 2 over to port channel 1. And if we ping the destination, we see that we maintain connectivity. So from a configuration point of view, the only thing that we changed is just that one checkbox under the virtual NIC. What's more important about this, really behind the scenes, is what hardware actually supports this. So if we go to the UCS site, let's go to cisco.com/go/UCS. And then let's go to compare the physical adapters. Okay, so adapters, and then there should be a compare models here somewhere. Compare all VIC adapters. And what we're looking for is the row that says failover handling. Okay, hardware failover, no driver needed. Okay, no driver needed, what it's talking about is the OS. So right now it doesn't show any of the legacy cards. There used to be another tab here that was for the Intel, the QLogic, and the Emulex cards, which were Gen 1 cards for the UCS. Now these have been replaced by VIC 1240 or the 1200 series and the 1300 series. Difference between them is what is the uplink bandwidth, where the 1385 I think is what I was referring to before. No, I'm looking for the one that is for the B chassis. Be 1380. So 1380 has 80 gigs of throughput. It's 40 on A and 40 on B. The difference between this one and this one, so 1280 versus 1380, notice that both of them have 80 gigs. The 1280 is 4 by 10. So think of this as the physical adapter. It's 4 by 10 on the A side and 4 by 10 on the B side for a total of 40 on A, 40 on B, or a total of 80. Okay, the difference though is that an individual flow is theoretically rate limited to 10 gig because you cannot load balance a single flow over multiple physical links of the port channel. Now, if I had 8 flows going at the same time, I could load balance one per channel of the 10 gigs. But so this would be the 1280. The 1380 has one channel of 40 on A and one channel of 40 on B. So theoretically, even though they both have 80 gigs of access total, theoretically the 1380 is more efficient because the flows can go above 10 gig. So if you're downloading, let's say FTP, you can use up to 12 gig. Whether this is realistic or not, depends on the I/O load of the server. But any of the new servers that you buy, they generally should have 1380 as opposed to 1280. But the blade support is pretty much the same, which is going to be either the M3 blades for the 1280, for the 1280, and then 1380 is going to be M3 and M4. Okay, the Gen 1 and the Gen 2 blades are end of sale, so unless you have an older blade that's running Generation 2, then you wouldn't see this card. But the form factor is physically the same. It's just you plug it into the board. Notice the difference though is that this is PCIe 2 versus PCIe 3. So it's got more lanes of access to the CPU behind the scenes. Okay, the key point here is that all of these do support fabric failover. Okay, there's a question here. So it's the vETH representing the vNIC that's pinned northbound, not the vNIC itself being pinned correct. So there's the vNIC is basically just a logical attribute. And then what the system is creating behind the scenes is the virtual Ethernet. The virtual Ethernet is basically just a VN tag that is coming from the adapter. So again, if we look at the physical details behind the scenes from the CLI, we know that the virtual Ethernet is corresponding to number 706 in this case. So if we show interface vETH 706, it says that this is chassis number 1, slot 5. The virtual NIC is called ETH1. So this is the string from the profile configuration point of view. And it says that this is bound to port channel 1285. So if we look at the show port channel summary and look for 1285, 1285 is going physically to ports 1117 and 1119. These are the traces behind the scenes that are physically sending us towards blade number 5. So even though from a configuration point of view, we're creating a vNIC, behind the scenes, what the system is really doing is creating the vETH. vETH has a particular virtual interface tag number that's put inside the VN tag, the 802.1BR for Bridgeport extension. And then somehow it's signaling down to the server. If you get traffic with tag ABC, it really means that you're using virtual Ethernet number 706, and it's this particular traffic that goes down to the OS. So this is the way that it's said from the card point of view, that the OS does not have to have support, that there's not a specific driver that you need to install. The reason why is that the VIC adapter itself understands the VN tag format. So it's basically like the fabric extender is the card. The parent switch of the fabric extender is the I/O module. Behind the scenes, physically in the chassis, you have the I/O module to the VIC traces, and then the VIC figures out what logical server, what logical interface that the traffic is ultimately going to go to. Okay, the other way that we can see this is from the GUI. If we go to the hybrid display, okay, so from the GUI, we're going to go to the main equipment tab. Then I want to say that this is under chassis. And let's click on, so there should be a tab up here that says hybrid display. Let's go under chassis, chassis number 1. And hybrid display. Okay, this shows us the resulting physical connectivity of how the system is logically set up behind the scenes. Okay, so again, this is under equipment, chassis, chassis number, and then hybrid display. So what this is showing us is that we have Fabric Interconnect A, we have Fabric Interconnect B. There's 2 links that are going down to I/O module A, 2 links that are going down to I/O module B. Then behind the scenes, there's these host-facing interfaces, the HIFs, host-facing interface that is ultimately going down to the blade. And then if you click on the individual port here, it should tell us what number this is. Backplane port 1/19 and backplane port 1/17. So if we think about the blade numbering convention, the blade numbers would be 1, 2, 3, 4, 5. Okay, so this is the physical server that we're talking about here, slot number 5. And then if we click on the traces there, it should tell you where this is going to. So I'm not sure if it's chosen on the server side. Let me click it again. DCE interface 1. So the host-facing interface of the blade is going up this way. It goes up to port 117. Okay, the other one is going to 119. And then notice that there's 2 more that are going the other direction. So one is going this way, which is 227, and the other one is going to 225. But notice that these are yellow. These are yellow because there is a failure northbound. Because basically, from the FI's point of view to the physical network, I cut off the connectivity here. So even though these ports are green, the uplinks are yellow, which means that the failover has occurred from the blade to go that way and then out up to Fabric A. Okay, but notice here, a really key point here is that the I/O modules do not have an east-west connectivity between each other. This link here is the L1, L2. That's only for the cluster, or in other words, just for the config synchronization, not for the control plane synchronization. And that's why we saw ultimately when we looked at the CLI and looked at the show MAC address table output on the FIs, that they see a different view. So Fabric Interconnect A knows about the 0001 address, Fabric Interconnect B does not, because they're not syncing the CAM table. Okay, this also means that from a virtual machine design point of view, if you have 2 servers that have east-west connectivity, let's say you have a web server that's calling a database, ideally you would want to pin both of those VMs to the same fabric, pin them both to A or both to B, so it means that the traffic goes up to the FI and then back down. Otherwise, if you have one server NIC pinned to A, another server NIC pinned to B, and you wanted to send traffic between them, what you would have to do is to leave the A fabric, go from the A fabric to the northbound switch. The northbound switch would layer 2 bridge the traffic, then come back down out the other channel, and then back down to the blades. So you have to physically go out of the chassis up to whatever the layer 2, layer 3 edge is, switch the traffic or route the traffic, and then come back. Okay, this is if we have one NIC on A and one NIC on B. If we have both of them pinned to A, the traffic would leave the chassis, go up to the FI, and then come back down. Assuming it's layer 2. Anytime it's routed traffic, the fabric interconnects don't run layer 3. So you'd have to go to your northbound default gateway, route the traffic, and then come back down to the destination. Now, I'm assuming, and this hasn't actually been publicly announced yet or released, so I don't really know what the exact features are, but the next generation of the Fabric Interconnect is going to be an ACI leaf. So you would physically uplink the Fabric Interconnect to the ACI spines. I'm assuming that they're also adding layer 3 connectivity in there. So it means that you would be able to route locally. The VTEP, the VXLAN tunnel endpoint, would exist on the Fabric Interconnect. And then we'll see what changes in the design, but they haven't actually released that yet. But otherwise, as it stands outside of ACI, if I had VLAN 10 and 20 that wanted to reach each other, so I have 10 here, I have 20 here, even though they're on the same fabric, I need to go up to 5K1, route the packets from 10 to 20, and then come back down and then go to the destination. So there does have to be some foresight and planning here where the servers are located, what their VLANs are, if you have lots of traffic that are going between two servers that are inside the same physical chassis.